Chapter 7, the quantum mechanical model of the atom. Until the beginning of the 20th century, it was believed that all physical phenomena were deterministic. What does that mean? What does deterministic mean? It means that you can look at an object's present state, its momentum, its direction, and predict where it's going to go. And for large objects, that's true. If you throw a baseball, even if you haven't studied physics, you can predict pretty close where it's going to land, right? You know, it has a trajectory, and you can predict what's going to happen. And so I think people just generally assumed that that was the case for all objects, regardless of their size. Well, at the beginning of the 20th century, work done by many famous physicists discovered that for subatomic particles, the present condition does not determine the future condition. So you can't really predict what these little particles are going to do. And these were the famous scientists that worked on this. And you probably recognize some of the names: Einstein and Bohr, and perhaps Schrodinger, because he was famous for his cat, which wasn't actually his cat. We don't even know if he had a cat, but anyway. So quantum mechanics is what arose out of this. And quantum mechanics is a foundational idea in chemistry. Because of the quantum mechanical model, it explains the periodic table, it explains the behavior of the elements in chemical bonding, and it provides a practical basis for lasers, computers, and all kinds of other applications of chemistry. So quantum mechanics is really important, and that's what we're talking about in this chapter. So we have to think about the very small. Electrons are incredibly small. They are mind-bogglingly small. If we think about a single speck of dust, a single speck of dust has more electrons than the number of people who have ever lived on Earth in all of time. Not just the people that are living on Earth now, but have ever lived. In a speck of dust, number of electrons. Electrons are just unbelievably small. And yet electrons are really important, and their behavior determines much of the behavior of the atoms. We can't directly observe them. We can barely get a fuzzy image of the atom itself, and the electrons are much, much smaller than the atom itself. The other tricky thing about electrons is that because they are so small, if you observe it, the process of observing it changes its behavior. Even shining a light on the electron causes a change in its behavior. So it's impossible to directly observe electrons. Okay, we're going to watch this video. And it's on the link. This video is in the playlist on YouTube for you YouTube people, so you can go watch it as well. So that thought experiment, he did not actually do it. Okay, no cats were harmed. The thought experiment is to demonstrate how absurd the behavior of these microscopic, submicroscopic particles, the subatomic particles. It just doesn't make any sense when you apply those ideas to normal things. Things cannot be in the same place at one time. They can't be two different things at the same time. And yet subatomic particles definitely seem to behave like that. Here's a couple of awesome quotes. So Bohr and Schrodinger and Albert Einstein were all involved in this. And Bohr said, "Anyone who is not shocked by quantum mechanics has not understood it." These guys did not like what they were finding. Schrodinger wrote, "I don't like it, and I'm sorry I ever had anything to do with it." Right? Okay. Albert Einstein attempted unsuccessfully to disprove quantum mechanics up until his death. He didn't like it either. Nobody liked this. But all the evidence pointed to this, and so they're investigating this, and they're like, we don't like this. We like Newtonian physics. You throw the ball in the air, and it's going to come down. It's going to follow rules that we understand. The quantum mechanical model is a theory that explains electron behavior. It explains the manner in which electrons exist and how they behave in atoms. And it helps us then to understand and predict the properties of atoms that are directly related to the behavior of electrons. And many of the properties are related to the behavior of electrons. Why are some elements metals and others are nonmetals? Well, it has to do with the electrons. Why do some elements gain one electron to form an anion, others gain two? Quantum mechanics explains this. Why are some elements very reactive and others are practically inert? Why in other periodic patterns that we see, that doesn't make any sense. Why in other periodic patterns we see in the properties of the elements? It explains the periodic properties that we see. My goodness.